In this video, we're going to take a look at the standard form of a linear equation. This form is particularly used while finding the x and the y intercepts. It's probably the easiest form to use in that regard. In general, standard form of a linear equation is when both the x value and the y value are on the same side, and that will equal some other number by itself over here. Generally speaking, A, B, and C are all real numbers. Okay. And A and B cannot both, and the key word here is both, equal 0. So either A can equal 0 or B can equal 0, or both of them can be just regular numbers, but you can't have 0 equaling some other number. There has to be x or y in the equation, which means one of the coefficients, one of either A or B, needs to equal 0. Okay. Traditionally, what also some people will say with standard form, even though our book doesn't specify this, is A and B have to be integers. So in other words, they cannot be fractions. Okay. And the other thing that standard form, some books will say, and some people will hold to, is that A needs to be positive. Okay. So the x value needs to be positive in order for it to be standard form. Now, what will end up happening and how this is used is that if I tell you that, say y is equal to 1/3 x minus 4, okay, and I want to put this in standard form, I need to move the x value over to the left-hand side. So I need to subtract 1/3 x from both sides. That will simplify out, and I get negative 1/3 x plus y is equal to negative 4. Now, according to the book, this is technically standard form according to our book, but a lot of places this is not classified as standard form. I need to get rid of this fraction. So basically what I need to do is multiply through by the denominator of that fraction, okay, which in this case is 3. Also, a lot of places, because this is negative, I need to get rid of that negative, so I'm going to multiply through by negative 3. So simplified out, negative 3 times negative 1/3 is just 1, so it becomes x, becomes minus 3y when I distribute the negative 3, equals positive 12. Okay. So this is classified as standard form. Okay. To find the x and y intercepts, what I can do is I can take this equation. Okay. X and y intercepts, by the way, are if I have a line. Okay. This would be the x-intercept because it's where the line crosses the x-axis. And then y-intercepts, we've already talked a little bit about, is where it crosses the y-axis. Okay. And based off this equation up here, I could tell that the y-intercept is negative 4 pretty easily. But the x-intercept, I don't know. Okay. The key part with this is that for it to be an x-intercept, I have some sort of x value. Okay. But my y value will be 0 if it is a x-intercept. For y-intercept, okay, I have a 0 for x, and then I have some sort of y for the y-intercept. How I can find that from the equation revolves off this property, that for an x-intercept, I am going to plug a 0 in for y. The reason being is because my y value always has to equal 0. So basically what ends up happening is it crosses this off because it's negative 3 times 0. So here I'm left with x is equal to 0. It becomes, whoa, why did I get 0? Sorry. about that. Okay, my mistake. It should equal 12. So in this case, my x value would equal 12. Obviously, I'm not following this picture. Okay, so my x-intercept is x equals 12. The coordinates would be 12, comma 0. Okay, for my y-intercept, I'm going to do something very similar. Except for plugging a 0 in for x, I'm going to, 0 in for y, I'm going to plug a 0 in for x, which means that gets rid of that part. I'm left with negative 3 is equal to 12, so I can say that y is going to equal negative 4. Just by dividing by negative 3, divide by negative 3, I get y is equal to 4, which means my coordinates are 0, comma, negative 4. So that is my y-intercept. So this is basically how we work with solving, putting equations in standard form, particularly with using the integers. This would be solving using integers, is the directions I believe this book uses, okay, to classify that particular way of writing standard form. I don't think it does much with the negative sign in front, but it's always a good thing to be able to be aware of. And then this is the solving for x and y intercepts. Okay, which is kind of essential. So anyway, that's where we're at. So hopefully this has been helpful. We did cover this last year, so hopefully this will be a little bit of a review for you. The one other thing that I would like to is if it asks for the equation of a vertical line, remember that the slope is undefined. And this is the one equation of our linear function, the one linear function where it's not going to be a function. So let's say I had a line passing through right here, vertical line, passing through x equals 3. This equation will always be in the form of x equals 3, because it can't be in the form of y equals, it's not a function. The reason being is if I pick any point on here, this is 1, 3, this is negative 2, 3. Okay, you'll notice, whoa, sorry, rang this stuff the wrong way this morning. This is going to be 3, say 1. This is going to be 3, negative 2. What you'll notice is the x value is always 3, so that's why it's x equals 3. If I ask for a horizontal line, okay, if I draw a line, okay, and let's say this is 4, okay, at y equals 4, the equation will be in the form of y equals 4. Reason being, the slope is 0, so if I plug that in, y equals 0x plus 4, what happens is this can just cancel out. So that's why it's just 4. And once again, if I was to pick any point on this, the x value could change, okay, but the y value will always be 4. Okay. So hopefully this has been helpful to you.